Hi guys, we're going to talk about the mole today. Not that cool furry guy right there, but the chemist mole. So before we talk about the mole, let's talk about a few things that you should already know. So if I tell you I have a dozen donuts, you should know that there are 12 of those donuts. Same thing if I have a ream of paper, I have 500 pieces. So those are things that we remember use as conversion factors. They mean the same thing. It's just they're two different units. Okay. In chemistry, we do have what we call the mole. It is the chemist's counting unit. The reason why we need this is because when we talk about atoms, we're talking about very, very, very large things. Or not large things, we're talking about very, very small things. So we need a very, very large number to understand that. So when I tell you I have 1 mole, I have 6.02 times 10 to the 23rd of those things. So if I have a mole of donuts, I have 6.02 times 10 to the 23rd donuts. That is an awful lot of donuts. Okay. So notice how this number, though, is an amount, the number of things that I have. So if I take a look at my giraffes and my donuts, if I have 1 dozen donuts and 1 dozen giraffes, how are these two things the same? Hopefully you said that these are the same because you both have 12. I have 12 donuts, I have 12 giraffes. What if I told you that I have 1 mole of donuts and 1 mole of giraffes? How are these two objects the same? Hopefully you said you had the same amount again. You had 1 mole of donuts, so you have 6.02 times 10 to the 23rd donuts. You have 1 mole of giraffes, you have 6.02 times 10 to the 23rd giraffes. Now, let me ask you a different question. How are these two things different? How is my 1 mole of donuts different from my 1 mole of giraffes? Hopefully you said size or mass, okay? 1 donut does not weigh the same amount as 1 giraffe, okay? So even though I have the same amount of things, their masses are different. See, here now we got to look at something that we are able to use in the lab setting is mass. The molar mass. The molar mass is the mass of 1 mole of a substance. So I'm not going to sit there and count out 6.02 times 10 to the 23rd of atoms if I wanted 1 mole of carbon atoms. It's a lot easier for me to get their masses on the scale. So how do I determine this? The molar mass is equal to the average atomic mass. The average atomic mass is from your periodic table. So if you haven't pulled out your periodic table yet, you need to. So 1 mole of carbon is equal to 12 grams of carbon. 1 mole of magnesium, 24 grams. 1 mole of oxygen, 16 grams of oxygen. So you'll notice that 12 and the 24 and the 16 all come from the periodic table. Okay. Now, the molar mass. So if I had 1 mole of potassium, how do I determine the mole of potassium? I just look on the periodic table. So potassium's average atomic mass is 39.10. So 1 mole of potassium is equal to 39.10 grams of potassium. Water now. How do I determine the molar mass of water? The thing you need to remember is, what does that H2O represent? Okay, I have 2 hydrogen atoms and 1 oxygen atom. So I have to take 2 times the mass of my hydrogen, which on the periodic table is 1.01, plus then 1 times the mass of my oxygen, which is 16, and add those up. So the molar mass of water, H2O, is 18 grams, or 18.02 grams. So now what is the molar mass of my calcium phosphate? You should have determined that the mass of your calcium phosphate is 310.8 grams per mole. The reason why it's grams per mole is because that is telling you that's how many grams are in 1 mole of that substance. Now let's take a look at percent composition that you've been doing percent pretty much all your lives. But here we're going to talk about percent by mass of each. thing you need to remember, percent is part over whole. And then, of course, times 100 since it's percent. So let's take a look at water again. So I want to know the percent hydrogen and percent oxygen. And the thing you need to realize, because it's 2 hydrogens to 1, it's not equal amounts. Because remember, hydrogen atoms actually weigh a lot less than your oxygen. So notice the bottom number for both of those. They're the same because that is the mass of the whole compound. That is the molar mass of that compound. The top number is just the mass of that particular element that you have. So for hydrogen, I have 2 hydrogens times the mass of hydrogen. So that's how I get my 2.02 divided by the total mass, 18.02, multiplied by 100. Same thing with my oxygen. 1 times 16, because that is the mass of oxygen, mass of oxygen. So the top number is 16, and the bottom number is still my 18.02. So you'll notice my percents of hydrogen to oxygen, there is a lot more oxygen in there than hydrogen because oxygen has a higher mass.